Hey everyone, this is Cses and welcome to my channel Code Disk. Let's solve the problem playlist. So in the first line we will be given with a number that will be the size of the array, and in the second line we will be given with the array, and in this array we need to tell the largest sub array with non-repeating number. That means in that sub array it has to be unique numbers. So in this case we have 5 as the largest. 5 is the window which has the largest non-repeating numbers present in them. Let's see how the number is 5. So if I go here in this window, in this sub array subsystem, in this we found this 1 to be repeating. So till here we found that 2 is our answer, right? Because this window has unique numbers in it. Now if I take this window, and this 2 is repeating, right? In this window 2 is repeating, so we won't take this. We will have till here. So this will be 1 2 3. This window has 3, so this is clearly bigger than this. We should keep this answer. Then we should start with this window, right? Because this was repeating here, so we will start with this window. Now this window till here, this has unique numbers. If I take this, then 2 would be repeating, so this will be 1 2 3 4 5. So this is our answer. And if you take any other window, if you take this also, let's take this also. If I take this also, then this would be repeating right here. So we will take this window now, because this has unique and this is 3, but this was the largest window of 5, so that is our answer, not 3. Great. Okay, so before converting to the Gamify model or the Warrior King model, we should have an intuition how we thought of this, how we got to know that this is a Warrior King model. So we will start from here, and at the beginning everything is 0, so our result is also 0, and we are starting from here. So we encounter first number, and which is 5, so we store in this 5 as, because we are in this video in this window, so we should remember that we have found 5, and we will move forward. Now 7 we found, so and our result would be 1, right? Because we have this in win 1, so this will be here. Now we will be here, we will move forward, and we will be here. We will see 7 is not present in this data structure which we are creating. For the timing, let's say this is an array which we are creating, so 7 is not in this, so the window will become, size will increase, and it will become 2. Moving forward, we encounter 3 is also not present, this will be 3. Now at this point we found 2, and 2 is also not present, 2, and this result will be 4. So we see 3, and if we see that this 3 is present in this array, right? So we should stop, and our window which we were saying ends here, right? This window ends here, so totally we have 4 number, and we can't include 3 because that would be a repeating character. So we should start a new window. But where we should start a new window? Definitely from this point, right? We should start from here, because in this window, this, if we include this, then this would be repeating, so we should start from this window, right? From this. But to do that, we should have something to remember that we saw this 3 at this index, right? We should have something which can tell that we saw this number 3 at this index. So you should start a new window from after this index. So that means we need to store the indexes also. So let me just write the indexes: 4 5 6 7 8. So we should store, in some data structure which stores the key and value pair, key being the number and value being the indexes. So these are indexes. Now if we will be here, then okay, we will check. How will we check? if this number 3 location is present. Yes, it is present. What is its value? Its value is 3, right? Its value is 3. That means it is this number 3 is present at 3. You should start a new window from this location plus 1. This location plus 1. So we will start from this location, and now at this point of time we should have some other pointer also. We should point it here now, because we are standing this black pointer is standing it here. So we should have some pointer. We should be standing at this index plus 1, so that we can tell the length of this window. Now you are getting, right? We need to tell now this new window is starting from here, so we should have some pointer. We should point at this new window, so that this one will be keep moving forward, and we will have this pointer, and subtracting this black pointer, we will have the length. All right, so this black one will move forward. So now, since this 3 index would change, right? This would not be 3. Now we have seen at 5. Now we'll move forward. 5 is present. Yes, 5 is present. But wait a second. Does it is going to hamper in this red window? I don't think so, right? Because this 5 is present at index 1, and it is clearly out of this window, right? This red window, because this red pointer, this new pointer is standing here, and black pointer is here. So this at index 1, 5 is not going to hamper our window. So we will ignore this, and we will update this to 6, and we will move forward. Our window size is increasing. 4 is not present, so we will write 4 as 7. Then we will move forward, and yes, our answer would be, we have not changed our answer. So in this window, 1, 2, 3 and 4, right? This 4 would be there, but it is clearly less than to the previous window, which was here. So we are not going to change the result because it is less. So we'll move forward. Now at this 6 will be 8, and the window size would be 5. And now this black window and this red window is bigger, so we will have this answer 5. But yes, I forgot to tell how we are calculating the length of the window. So suppose you were here, then the length would be this black pointer minus the red pointer. So the red pointer is at 7, and the red pointer is at 4. So 7 minus 4 would be 3. But the numbers are 1, 2, 3, 4. So we should add plus 1. Why we are doing this? Because when subtracting, it will do the inclusive subtraction. So we should have this. We should we should add 1 more, plus 1. So this will be 1, 2, 3, 4. So what we are doing, we are having 2 pointers. We are saving the indexes, and we are sliding the windows, and having the largest window length as our answer. Now in the next slide, we will have a Gamify model to understand it even better. Okay, so now in this Gamify model, this is our array, but now this is no more array. This is our war zone or war land, and these numbers are our enemy. We will have 2 warriors, right? And this is warrior number 1, and this is warrior number 2, and these are the locations of the enemy. These 1, 2, 3, 4, these are the locations of the enemy. Now if you can synchronize with previous slide, these 2 warriors are nothing but the 2 pointers, and we will have a king. That is our just the result storing mechanism, and initially it is at 0, and everything is pointing to the first index, which is this one. So as told, we will have some data structure which stores the key value, key being the 5 and 1 being the index, or the location. I should say the enemy location is 1. Okay, now our warrior 2 will move forward, and the king is going to take it as 2 now, because this first warrior and this second warrior, their difference is 2 minus 1 plus 1, right? So that would be give us 2. So these two numbers are unique, and we will put this in our location chart. So 7, its location is 2. Now the warrior 2 will again move forward. This is also new. We will store and we will increase the answer, as it is the king is taking the answers. The king is taking the points, I should call. Then we will move. This warrior 2 will move forward. It attacks the number 2 at location 4, tells the location of number 2, which is at 4, and king takes the point, which is 4. Now the warrior 2 will move again, and it sees that the 3 is present at index number 3. So it informs the warrior 1 that I have found the number 3, or the enemy 3 at position 3. Come here quickly. So the warrior 1 will move to location number plus 1. Location number where the enemy was spotted, plus 1. It will move to that location, and now the new new thing will be warrior 2 minus warrior 1. So 5 minus 4 plus 1. So this will be 1, but it is less than the king's point, right? 4 is less than 1. It is less than 1, so king is not going to take this point. Alright, so warrior 2 moves forward, and again it sees 5, which is present at 1, but 5 is present at enemy 5 is present at location 1, but the first warrior informs that no issue, it is out of our window or out of our new attacks. So because this is saying this, not this, so now the length the point would be 6 minus 4 plus 1. So this would be 3, right? And we can see one number, 1, 2, 3. Great. Warrior 2 will move forward. It sees 4, the enemy 4 at 7. It is a new enemy. It register and increase the result. And now the warrior 2 moves forward. It is at 6, updates it and updates the result, so which will be 5, right? 8 minus 5, 8 minus 4, right? 8 minus 4 plus 1, so that this will equal to 5, and this point 5 is greater than the previous window, which was 4, so kings take this 5, and this is our answer. And now the warrior 2 sees the war zone is ended, the king wins. Great, right? So this was the Gamify model. Now we will write the same logic into our code. So let's head to our VS Code and write this algorithm. Code of this. So first we need to have the length of the array or the war zone. So let's call this as war area. So what this war area is, this is basically the L, the number of the size of the array. So we'll enter the war area. Now we need to have a array. So let's create a vector for this. So I will create a vector of integers calling it war zone, and we should have the indexes from 1. So I will increase by 1. This is basically indexing from 1. Now let's get this input equal to 1. I should be less than equal to the war area and plus plus. I will input the war zone. Alright. So if this has to be inputted, Then at index 1 we will have the 1, at index 2 we will have 1, again at index 3 we will have 2, like this. We will have the war zone, and these are the enemies. Now, as explained, we will have warrior 1 and warrior 2. So we will start the warrior 1 with, it has to point at index 1. So index 1, and also we need king, which is initially at 0. No, this is the beginning, right? So it is at 0. The point is the star point for the king is 0. This is basically the answer. And also we will need a data structure to hold the key and value pair. That means the key would be the number and the value would be the index or the location of this enemy. Alright, so let's define a map data structure. And if you have any issue with map, I have a video of it, you can check that. So we will have the enemy location here. So I will say enemy location. Now our warrior 2 and warrior 2 start from index 1. This warrior 2 has to go up to, it has to traverse the whole war zone. So it has to be equal to the war area. War zone is the area. Area is this, the size of the array. And warrior 2. Now what should we have to do here? We have to do, first of all, we need to check. What we need to check, if this is there, then do this. What we need to do, if the warrior 1, let me just write this first. If warrior 1, try to think the logic. Now we are just converting the logic into the code. If the warrior 1 is what? Is less than the enemy location. Enemy location war zone. Enemy location warrior 2. What is this? Let me just explain you. Warrior 1 is all basically, it does something like this. Warrior 2 moves like this, it moves, and we have to fill this data structure. So we can fill this data structure. Let me just first fill the, just leave this for the time being. We will have to filling the enemy location. So how can I do that? I will say that enemy location and this warrior 2, where warrior 2 is basically pointing, is carrying the indexes, right? So if this number 3, if this like this, wait. So yeah, warrior, if wherever warrior 2 is pointing, I should keep that in the enemy location. So this will be our warrior 2 is pointing to the location, right? Location, and it has to be go to the number. So how can I get that number? Number is stored in war zone, and I'm targeting the enemy in the array. I'm targeting the enemy. So war zone, warrior, simple, right? What is this line? This line is basically saying warrior 2, this is war zone, this is war zone. So let me just write here only. This is war zone. Wherever this warrior 2 is there, that means war zone, and warrior 2 is 3, right? It is at 3. So war zone is already, warrior 2 is at 3. So war zone at 3 is this number 3, right? So this has to be filled with index. So index is carried by warrior 2. So I will write warrior 2. Simple. So we have filled the enemy location. Now let's write the condition spelling is wrong, condition for king's points. So for that I will say if king is, and how we were taking the location, taking the length, I was saying wherever warrior 1 was pointing, so warrior 1, warrior 2 minus warrior 1 plus 1, right? We were doing this. If we have to find this window's length, I will say wherever warrior 2 is pointing, it is at pointing at 2. Wherever warrior 1 is pointing, it is at pointing at 1. 2 minus 1, that would 1, and we have to add 1 because the subtraction is inclusive. So the length would be 2. So I will say a simple condition: if king is less than warrior 2 minus warrior 1, and I need to add plus 1. If this is the case, then I would give king. If king is less than this, then I should give king this. Simple. If this is the case, then give the king the points. If this length, if the window size is more, if the window size is more, king takes the point. Simple. Now we have to write this warrior 1 condition. Let's study this warrior 1 condition. So at the enemy location chart, wherever warrior 2 is pointing, so warrior 2 is pointing at 5, its number, so warrior 2 index number, warrior 2's index number. So we'll write warrior 2 index number. So warzone, we'll write here warzone, wherever warrior 2 is pointing, so this line basically saying that, suppose warzone warrior 2, so warrior 2 is pointing at index 5, so array at 5 is number 3, so enemy location 3, we will get this 3, right? Because this is a map, so the key is 3 now. This key is 3. This will give this 3. So warrior 1 has to come at 3. But no, it has to come at 4, right? Because we have seen that this new window will start from here, not from here, right? So that's why we will add 1 to it. And warrior 1 will come at this. And we are putting this warrior 1 is if it and this location is greater. So we will give this whole to warrior 1. This location we will give to the warrior 1, and also and you see this will take care of this issue also. If warrior 2 is pointing at this index and this is 5, and we will check 5 is present and saying this is at 1, but our warrior 1 index is 4, right? This index is 4, so this is not going to happen. So that's why this condition is there. And then simply we need to just display the king. Let's try to submit this now. So it has been accepted, and this warrior and king model was easy to solve this problem. And just try to have a run this on paper and pen if you want to have a clear understanding of this part, because I have explained to my greatest effort, and it is very simple. We are looking at this map data structure. If the location is there, then I am just calling the warrior 1 to the incremented position, right? Why we are calling to that incremented position? Because this window ends here. We should bring this warrior 1 to here, and Secondly, this condition is giving the window size. So if this monitor is pointing at 6, this is pointing at 4, so 6 minus 4 would 2, and we will add 1 because these are 3 numbers. So this will 2 and 1, 2, 3. And King takes this, and at the end we are just filling the enemy location, which is this if so the number 4, its position is 7. Like this we are filling the condition, and at the end we will display the king. Great. Thank you for watching.